Let us look at quotient groups. Now, if N is a normal subgroup of G, then the set of cosets of N in G forms a group called the quotient group and represented as G slash N or G by N. So G by N is equal to the right coset subgroup N times A, where A is in G, or the left coset A times the subgroup N, where A is in G. So here this is the right coset and the left coset, and the reason they are equal is because N is a normal subgroup of G. Cosets of N in G do not form a group, then N is not a normal subgroup of G. So once we have arrived at the set of cosets of N in G, then we just verify whether it forms a group or not. If it forms a group, then it is a normal subgroup of G, that is N. And if it doesn't form a group, then N is not a normal subgroup of G. So let's take an example and look at this concept. Now let's say G is equal to the group of unit quaternions. Now here this is more of a subgroup of the unit quaternions. Let's treat this as a group. The center of Q8 in the previous session we saw is Z of Q8 equal to 1 comma minus 1. And we know that the center of Q8 or the center of a group is always a normal subgroup. So let N is equal to Z of Q8. So now let's look at the cosets. Cosets of G slash N, that is the quotient group, is equal to the subgroup itself, N, IN, JN, and KN. So here we are looking at left cosets, or more specifically, cosets of the quotient group G by N is equal to N, comma, plus or minus I, plus or minus J, plus or minus K. When we multiply any of these two cosets, how do we do that? X times N times Y times N is equal to X times Y times N, where X and Y are in G. So N is the identity coset. If I bring in this Cayley table, you will notice that the first row duplicates the column headings or duplicates the cosets. So N is the identity coset. Let's take the integral powers to figure out for which power this is going to give us the identity. So let's take the square. So I times N square is equal to I square times N. I square we know is minus 1 times N. Now, N contains what? It contains 1 and minus 1. So minus 1 times 1 is minus 1. Minus 1 times minus 1 is 1. So that means this again gives us back the identity coset. So which means I times N square is equal to N means the order of I times N is equal to 2. Order of the coset IN is equal to 2. Similarly, the order of J times N is equal to 2, and order of K times N coset is equal to 2. These cosets form a group and is called a quotient group, G slash N or G by N. Now here you can go through this and verify that this actually forms a group by looking at the closure property, associativity, existence of identity and existence of inverses. This quotient group of Q8 by Z of Q8 is equal to, remember the subgroup itself forms a coset, then we have I minus I, J minus J, K minus K. Since N is a normal subgroup of G, G by N is commutative, that is abelian. Order of G by N is equal to order of G by order of N, which is equal to 8 by 2, which is 4. This is from Lagrange's theorem. So elements of the quotient group N, I, N, J, N, K, N partitions the group, since the quotient group is made up of cosets. In this example itself, take another normal subgroup of Q8 and look at the quotient group so formed. So that was quotient groups. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.